All right, so trying this again. Lesson 6 on functions and relations. Kind of a different concept from what we've seen in lesson 1 through 5. We're going to be finding the inverse of a function. The symbol is f to the minus 1 of x, a slightly different function notation. It does not mean reciprocal, it does not mean divide, it's f to the minus 1, specifically reserved for function notation. What it's going to involve is it's going to involve x being transformed to y and y being transformed to x. Very interesting process. It's like x squared is inverse to the square root function, or tan x is inverse to tan to the minus 1x. You'll see, especially in those trig relationships, that the inverse notation is accented in the same way we're going to be using it. Remember, the function test is the vertical line test. I've starred that up here, and the function test is described by every x having only one y. I'm going to try and have this little preamble slide before a lecture so that you can reset your brain for the material that is to come. Let's turn over to the first page of the unit. So here we have the title, Functions and Relations, Lesson 6. It's on page 43 in your workbook. And we've got some nice definitions or descriptions of a function. We can see how A is clearly tracked to B in both sides. The first box is my x's, my domain. So the A's here are my x's, and the B's are my y's. And it's very clear in both of these cases that every x has a unique y. Every x is only trackable to one y. These are known as functions. Now, the inverse of the function actually involves just flipping the graphs around, or those diagrams around. You'll see that my label is here, which is B. This is actually what I want to call my new x. And the A is my y. And similarly, on the other side, my B is my x, and my A is my y. I'm starting to run into problems with the inverse of the double I example, because I actually am not sure whether the x value belongs to -2 or 2. And because it belongs to both of those, it will actually fail in the function test. If I were to graph that, I would end up graphing 4 and 2 and 4 and -2. Then 9 would come a little bit later, so 9 is 3 and -3, and that square root graph is being erased. This is the classic square root graph, and you can clearly see that graphing those points gives some indecision as to what y value belongs with 4. It fails the function test. So if I were to try that vertical line test, that would fail. So in the case of the inverse, the first one is a function. I'm going to use check mark for that. The inverse of the second one is not a function, and I'm going to use an x to represent that. A really nice note here by my lovely policeman. The domain of the inverse is the range of the original function. The range of the inverse is the domain of the original function, because you are literally making your x's turn into y's and your y's turn into x's, which flips the domain and range. So x becomes your new y, y becomes your new x. And it's possible that the inverse is not a function. The inverse of class example 1, you're getting dressed to come to school this morning, you put on your socks and then your shoes. The inverse would result in you being in the original condition, which would involve taking your shoes off and then taking off your socks. So remove your shoes and then your socks. And we can explore inverses with some simple examples, simple word examples, and then we'll look at some graphs. The inverse of multiplying by 2, how do you undo that? You divide by 2. The inverse of squaring is the square root. The inverse of taking the reciprocal is to take the reciprocal. So the inverse of taking the reciprocal is to take the reciprocal again. And the inverse of dividing by 3 and then adding 1 is to reverse that, subtract 1, and then multiply by 3. Some of these are unique, multiplying by 2 and dividing by 2. Those are unique. The inverse will be a function. Square roots are not a function. We've seen that because you can get both positive and negative. Taking the reciprocal is a function, and it would be a function to subtract 1 and times by 3. Let's turn the page over. So I've turned the page over and we're looking at class example 3, and we actually get our first opportunity to build inverses by simply playing the game of flipping x's and y's. So we could teach junior high students to make inverses. Hey, turn your x's into y's and your y's into x's, or just flip those ordered pairs around. So I'm going to make up that list: -2, -4, -1, -2, 0, -1, 1, 0, 4, 2, and 8, 3. Now I'm going to have to build a graph of that data. So I'm going to graph the blue points that I just created, and then I'll graph the original points. We'll take a look at those two graphs. So I've graphed the blue data, and I've labeled that as f to the -1 of x. Now I'm going to graph in black. Actually, I'll use green so it stands out a little bit more, the original data. So I've got green data and I've got blue data, and you'll kind of see that they appear very close. In fact, we say that the inverses are created by reflecting one graph in the line y equals x. So I've drawn the line y equals x. Try to hit those points. The equation of the mirror line is y equals x. And that's what we're actually doing. We're making y equal to x and flipping that around. That will always be true. How we make the inverses is worrying about this mirror line. I really like the table of values method. We're going to try that one more time and then take a look at the assignment. So I'm going to create the table of values from the original data on class example 4. So I've turned the page over again. I'm on page 45. And I'm going to take those circled points, create the table of values. I read it as -3, 0, 0, -3, and 3, 0. And I can make the inverse by simply flipping those numbers around. I'm going to make the inverse on this side. So 0, -3, -3, 0, and 0, 3. And what I've noticed about the graph those points, see what they look like. So I've graphed the points, and actually 2 of the green points are actually overlaying the original graph. So I'm going to try to make that really big and accented. Maybe you can take a highlighter and make that big and accented for yourself. So the green graph is the graph of f to the -1 of x, or the inverse of x. And the red data corresponds to my f at x. Now the original graph was a function. The original graph was, yes, function, but the inverse graph is no to function because the vertical line test actually fails. If you were to take a vertical line through those points, the vertical line test fails. We've got one question to do algebraically. There's always graphing in algebra. So let's slide down. And now we're looking at our first algebraic representation. So the original graph, y equals 3x plus 2, you can make your calculator graph that. You should recognize that as a line, which is in fact a function. So that's always good. Now I'm going to make the inverse. I'm going to try and change color on you. And to make the inverse, remember what we have to do is x has to become y, and y has to become x. And then we get to resolve for y. Resolve for y or isolate. So I'll do that in blue. My y now is going to become known as x. My x is going to become known as y. And then I have to resolve for y. That gives me x minus 2 over 3 to be equal to y, which is the same as 1/3 x minus 2 over 3. So you could more clearly see the slope and the intercept form. That's also still a line, and lines are functions. So both the original graph and the inverse are functions. So the inverse is a function, which I want to say check mark 2. The original one was a function, which I want to say check mark 2. Now we're actually ready to tackle that assignment. Remember, the assignments are on that pink sheet of paper. This is lesson number 6. So for lesson number 6, we want to do questions 3 through 5, 6A, CE, 7A, 8A, and then 9 through 11. Thank you very much. I hope you had a chance to watch this before class started. Otherwise, we'll take a look at it again next class. Enjoy your evening.